Hi everyone, welcome back to Vic's Projects, and today we're back on the Motocompo. Going to turn this into this. It's been a while since we played with a little Motocompo, so for a bit of a refresh, we've gotten all our measurements, we've done some calculations, we've put it in CAD, and we figured out it doesn't fit. So I think our problem might not be quite as bad as it looks. We can actually use the shape of our tyre, I think, to our advantage. So if we have a quick look at the Motocompo of where this tyre is going to sit, I think we can sneak a little bit of extra room when we look at this problem in 3D. So since the last video, my friend's been busy in the machine shop making up the bush that we designed. So this guy is all good to go and just ready for us to make the swing arm. So let's crack on making that. So I initially tried using CAD to find out what shape this should be, all the angles and all of that. And I figured out my CAD is terrible. So we're going to try a new trick. We're going to use our bench and just see if we can freehand it. So our critical measurement is from where this finishes, this edge, all the way to the back of the rear tyre is 5'11". So we're going to mark out on our bench exactly that. And from that, we can now start to draw out how this is going to work. So somehow I need to bend this tube so it comes around here, clears the wheel and gets into this guy. It's going to be quite a tight bend. One question I guess you're asking is what sizes are we actually going to use for these tubes? Well, the one that forms the base of the swing arm, the bush, where the bush lives anyway, he's actually set by the bar that Honda gave us to begin with. So I just put some sensible sizes around that, really just on what tubing's available. So we've gone for a 30mm OD on this guy. The next one, the one that we've actually got to put the bend in, and the one, shit. GoPro, stop recording. Sorry about that, we ran out of electricity. We're in the depths of winter, so the solar panels are struggling to charge the batteries that we've got, especially with all these lights. They take up quite a bit of juice. So where were we? We were on the smaller one, so the one that actually will make up the arm. Hold on 1 second. So the smaller one, we've got the larger tube that's going to sit here and hold the bush, and then the smaller tube will live around here to make up this part of the swing arm. So I had a friend run some numbers. He reckoned 25mm OD was probably the ideal for this, based on the stresses and lows. However, trying to get something that I can bend 25mm is really tricky. Over here in the UK, we've got a couple of standard plumbing sizes, so you can get a bender really cheap. What is it? 15mm and 22. So we're actually going to go for 22 OD on the main pipe. Well, we can actually form it, so that's a bonus. If we manage to smash it, then we'll just have to start again and make a new swing arm. But hopefully this will take the load. Now moving back to our bench, I've put a bit of masking tape down so we can actually see where the wheel's going to live, where its axle is. So clearly this wheel's going to extend out a bit back here. Now our bush is going to live on that point there. So I've just roughed out this guy a bit bigger and we can chop him down. So he will end up living there. Now we need to bend and then cut down this tube to make our swing arm. So ultimately he's got to weld onto there and meet our axle so that our axle can come through him. So I've got him a bit oversized, so we've got plenty of room to maneuver. On the way this bender works, I'm going to need to mark where I want the bend to start. It will then give a bit of a radius, about that sort of size. But because it's all going to be by eye, I'm going to give myself a bit of room. So ultimately, this will probably finish around here. So if I give myself a bit of room to move stuff back and forth in case I don't get the bend in just the right place, and then plenty of room up here for it to come out, and then I can notch that tube down, and we can be golden. So by eye, give myself the room there. I probably want this bend to start around, what do you reckon, around here? Yeah, that's probably about right, isn't it? So let's bend that up, or start at least, and see what it looks like. So, give myself a bit of space, sit on there, give this a little bit of extra leverage, and let's see how that looks. So it's getting there. This guy needs to land about here, so we just need to keep bending it little by little. It's much easier to add bend than it is to take it away, so we'll just go slowly until we get to roughly where we need to be, and then we can do the other side. You do that twice and you end up with something like this. Now before we get too carried away actually notching these tubes and welding him onto there, we've got a little issue. If we leave this tube just like this, when we actually come to notch it to slide this axle on, we're going to be left with very small amount of metal and actually no real strength right on that critical join there. So got myself a nice big thick bit of plate. What we're going to do, I've chopped a little bit off here, this will end up sliding in there, a bit of a bigger one anyway. So we're going to compress this down, and actually all this area will be pretty much solid alley. So let's just have a test with this offcut in the vise. So it didn't come out too bad. We've got these funny little flats here, but I'm sure it'll be all right. And if we compare it to how it was originally and put it alongside where the wheel is, or the axle is rather, you can see we've got a lot more exposed metal to give it a bit of rigidity, a bit of strength. So actually that's the profile there of this guy here. Now we've got two options to make this drop out. We can either have a slot like this, which allows us to move the wheel in and out, back and forth, and accounts for any misalignment that we get when we actually weld things up. And then we've got this option here, which allows the wheel to just drop on and is actually a bit safer should everything come undone. Either way, we actually start with the same size piece of metal, so we're going to cut that out from our big thick nice bit of alley here. now getting close. We've got all our bits of metal ready to make our swing arm. We've just got to notch these tubes and then find a way to hold it all nice and square and nice and tight so that we can actually go around and braze it and get it all strong and together. So the way we normally do that is with a jig. So we've got these pieces of angle iron here. We've got some M10 threaded bar, and this will actually start forming how we hold it all together. So if we look at this guy here, that will just sit on there nice and tight. We can turn these guys here to just move it around. For the central bar, I've had these machined up, so these cones, these can actually go on that bar like that. We then put him on there, another one on top, and now that holds it nice and central, and we can obviously move that back and forth to get it all nicely aligned. Let's get cracking. So I've spent about an hour trying to get all of this all in the right position. Looking at the data sheet, that gives one number for this distance on the axle of our electric motor, but actually measuring it, which was a non-trivial task, I get a slightly different number. So yeah, a few years working in engineering has told me never trust the data sheet, and that was certainly true here with our nice Chinesian motor. Right, now that this is all set up, this guy is all central to where it needs to be. So that is the center line of the actual wheel once it's on. We now need to notch these tubes. As you can see here, I've put some marks, and that is where the tube finishes. I've now cut this one just as a bit of a guide on the angle. So with this, we can now just put a quick mark on there to help us start cutting out these tubes. So because these are really rough marks, what we're going to do is cut, giving ourselves plenty of room, so that we can cut a bit, check a bit, cut a bit, check a bit, until it's absolutely perfect. Wow, how good does that look? I'm generally impressed with myself. This is the first time I've ever done something quite like this. So wow, yeah, I don't even know what to say. Well, I guess one thing I do know what to say is this, there should be a fair amount of strength in there once it's all brazed up. However, I think I'm going to add, just for a bit of belt and braces, an extra gusset. So that gusset's going to live on there like that, and just going to help strengthen up that whole area. Okay, one thing we need to do to make sure we don't set alight to our bench is, I've got some random offcuts here, so I'm just going to put these guys underneath like that to just protect the bench, make sure we don't set it on fire. Okay, Vic, quit stalling. You need to get on with this. You need to commit and braze this up. Fingers crossed it's all good and it all goes swimmingly, because I really don't want to try and make this again. Okay, stop talking, start doing. Right, so this has been cooling down for a while now. It is actually nice and cool. It looks all right from the top. I wasn't able to actually get underneath properly and actually do any brazing underneath, so we'll probably have to flip it over and do that afterwards. But I'm really pleased. So let's see if we actually can rotate it, pull it off, and it all stays together. It should do. That looks all nice and strong. So if I just, it's interesting, it's actually opened up a bit. This guy's come loose. It's a nylock on this side is actually all bubbled out, and we can see the where our heat shield hasn't really worked very well. There's a couple of scorch marks in the desk, but oh well, that's all right. That guy comes off. There we go. That looks, kind of touch, that actually looks like a swing arm. Let's check, see if the motor fits. Okay, this is the moment of truth. This is where our video could be a great success or not suitable for children. So it looks quite close. Holy moly, look at that. That is, well, we all knew it was going to work, right? We measured it 100 bloody times. Yes. Oh yes, this project might just work. Well, I hope that was as much fun for you as it was for me. That was my first time playing with metal in that way and doing that level of fabrication. Next time we're going to go into a bit more familiar territory and start playing with lots of power. Turns out the brazing doesn't give us much strength.